representing here. And therefore, when you combine the two together, you get the summation go all the way from minus infinity to plus infinity. Okay, so let's move on to the next slide. So, according to the previous slides, we can see that equation 39 says any periodic function f of t can be expressed as equal to the summation of ck tilde. This is a coefficient in the complex number multiplied with e raised to the power I k omega 0 t. So the question now becomes, how do we calculate this coefficient ck tilde, which is a complex number? How do we calculate that coefficient ck tilde? So to answer that question, we have to refer back to the old equation that we defined for ck tilde. Let me show you the previous equation. See the equation right here. If you look at equation 36, that will give you the definition of ck tilde. Okay? So basically say ck tilde is equal to ak minus ibk over 2. So because of that reason, let's go back to the next slide. According to that old equation I just write for you, if you remember, we can say ck tilde is equal to a k minus I bk over 2, according to the definition that we have earlier. So the factor 1/2 is here. 1/2 factor is there. 2 over t times this, that have the same meaning as a sub k. And then you have here minus I. That term is right here, minus I. And finally, the term b sub k, the blue one, is this integral right here. If you combine with the factor 2 over t, that together will give you bk. So this goes to as bk. Okay? So ck tilde is equal to 1/2 ak minus ibk. That's come from the definition. So equation 40 we can simplify a little bit, and the reason is because you can see we can simplify these two cancel out, so the factor become 1 over t, and then inside the integral we can see you can factorize the term f of t. You can factor it out. So what do you have left from equation 40 is this term right here in the square bracket. And then finally, we can see we can use the Euler formula. We can express the cos term in terms of the exponential form. And similarly, the sine term of an angle, we can express in terms of the exponential form like we have earlier right here, based on the Euler formula. And you still have minus I in here, that is remaining in here. So the formula for ck tilde is given by this. And finally, you can see something else will cancel out, because here you have a term e raised to the power ik omega naught t, and then here you have minus e raised to the power ik omega naught t. So these two terms cancel out. And the reason I say that is because you have a minus I, this I in here, cancel with this I in here. So at the end, all you have left is this minus sign here, the minus sign here, combine with this minus sign, and then you can add with this term in the front. So finally, you will have what you have will be just this equation here. Let me write out for you. This is equal to 1 over t integral f of t, and then the square bracket. What you have left will be e raised to the power minus I k omega naught t minus should become plus e raised to the power this again. So it becomes 2e minus I k omega naught t, and then divide by 2, divide by 2. So these two cancel out. So all you have is this term, which is a definition of the coefficient ck tilde. So that's it. To summarize it, we can see that we can express the Fourier series according to equation 39, where in equation 39 you need to figure out the coefficient ck tilde, and that coefficient ck tilde is given by the last slide that I just showed to you, which is equation 41. So that will be the end of the lecture. How long is this one?
It's plus 20.
35 minutes, you think?
20 minutes.
20 minutes?